All right, we are live. Hello, everyone. Welcome to a webinar on evaluating RAG applications. Really excited for this one. This has been in the works for a while. We've had some we've got some awesome guests. We've been working on some collaboration with the Ragas team for a few weeks now. So really excited about this, and then added in Pedro last minute as well because he has a really cool kind of like product that just launched. It's very relevant to kind of like what we'll be talking about. So minor logistics before we get started. This is being recorded. It'll be available at the link afterwards, and then we'll also put it up on YouTube tomorrow. The format that we'll do is quick intros by everyone, then we'll have a presentation from Ragas on what they're building. We'll hear a little bit from Will about what some of the stuff we're working on at LangChain, and then we'll hand it over to Pedro to talk about building an application. Like what as an application builder, what is he actually looking at in terms of evaluation? After that, we will then just go into general Q&A. So if you guys have questions about kind of like RAG evaluation, please put them in the Q&A box on the right. So if you look to the right, you can see there's a little chat box. That's probably where you're in by default. And then if you look below that, there's a little box with a question mark. Please put any questions there. We'll go through the ones that have the most votes, so you can vote for ones that you want to hear answered, and we'll answer them in that order. I think that's all the logistics stuff. Should be pretty straightforward. I'm really excited for that one, or for this event. So let's start it with some quick intros. Jithan, do you maybe want to go first?
Yeah. Hey, first of all, thanks, Harrison, for setting it up. Great to be talking with you guys and learning from you. But yeah, my name is Jithan. I'm one of the co-maintainers of Ragas. I used to work as an ML engineer previously, and then got into the LLM fever by this year. And then I've been like from that point, I've been focusing on how to make LLM apps and especially RAG apps much more reliable. So yeah, that's about it.
Awesome. And Shahul, do you maybe want to go now as well to round that out?
Yeah. Hi, I'm Shahul. I've been a data science professional for past 5 years, been training language models since 2018, and now full on maintaining Ragas. So happy to be here.
Great. Will?
Yeah, hi, I'm Will. I work with Harrison at LangChain. Been working a lot, especially on LangSmith platform, looking at our evaluations, trying to integrate better with great packages and frameworks like Ragas, and really trying to connect the dots between LangChain, LangSmith, and what everyone needs here to evaluate any type of custom application.
Perfect. And then Pedro.
Hey guys, thank you so much. My name is Pedro. I'm the founder and CEO of Tavern. We just launched Noah yesterday. We're just trying to really, get all the cool infrastructure and put in the hands of users, building workflows that are really easy and simple for them to get. So we've been building, an AI and LangChain since the beginning of the year. So really excited to dive deeper into it.
All right, and with those intros out of the way, let's hear about Ragas. What have you guys got for us today?
Yeah, I guess I'll share the screen now.
Perfect.
Okay, hope everyone can see the screen.
Yeah, good.
Yep.
All right.
All right. So Ragas is an open source evaluation framework that we built honestly for ourselves. So we were testing out a bunch of we were pretty passionate about retrieval augmented systems, and we were building a bunch of them ourselves. But there was no proper way to evaluate it. There were a couple of existing metrics, but like blue score, roach, etc. But they had very few, very poor correlation with human judgment, and there were many data sets and benchmarks to evaluate the retrieval part, but they were also not consistent with the data you see in production. So that was also not very good for evaluation. So we were focused we were trying to figure out how we can improve this evaluation, and we were thinking about that a bit, and all the learnings that we had was what we wrote it up in Ragas. So, but from the start, having a very thorough and well-tested evaluation pipeline is very important to build robust apps. while you can easily start off with a cool demo with like libraries like LangChain, when you're going into production and you have to bring in these engineering disciplines like having good test suite, having a good evaluation pipeline, so that your apps are reliable when they go into production and continue to say so. So that is one of the importance of having a very good evaluation pipeline, and that's one of the reasons why we focused fully on building Ragas.
Okay.
Yeah.
So Ragas as a tool focuses on LLM assisted evaluation, but before going to LLM assisted evaluation, we should be very much aware of why and where we should not use LLMs, and LLMs also comes with a certain set of biases that we should be really aware of, so that we can design paradigms that can bypass these biases. So I'll just discuss some of these biases that we are aware of as of today. One of these is that LLMs has a particular positional bias, because of which it will prefer responses to a particular position compared to other positions. So if you ask LLM to compare and select the best outputs from 3 given outputs, it might just prefer the output at position 1 because it just has a particular bias towards that position. And the output from the LLM can change whenever you change the positions of the outputs. And LLMs also have shown to prefer integer scores when assigning scores, and it never almost prints out floating point scores. So this is also a bias that LLM has. And when used to compare answers, even GPT-4 actually preferred answer from its own output, even when compared to answers from human annotated answers, because it is due to a style bias that LLM has. And then it also has a bias towards picking a particular number from a set of numbers. That we'll also see an example for that. And LLMs in general are also stochastic in nature, due to which it can give different scores when invoked differently. So using LLMs directly is not really a very good solution. And here you can see that I have generated basically 100 random numbers from GPT 3.5, and it picks up 7 most of the time. And this essentially shows a particular bias of the LLM, that it is actually preferring the number 7 compared to other numbers. And if this was an ideal system, it should have actually preferred or should have produced some uniform distribution. So
yeah, like Shahul said, using LLMs directly has a few biases, but they are also very effective, like when evaluating in a bunch of situations. They have very good correlation with human judgment if used in for specific situations. But so the goal with Ragas is, okay, we know LLMs have certain biases, but they also have some positives. But what are some methodologies so that we can work around these biases that they have and use it for evaluating retrieval augmented systems? And we came up with a few paradigms. So basically, for any RAG system, there is 2 components, which is the generation and the retrieval. And we need to evaluate both of them separately so that it gives you a holistic score of what is happening, or gives you a holistic score. So for the generation part, we have faithfulness and answer relevancy, which I'll talk about all these metrics and how they work down the road. But for retrieval, we have context relevancy and context recall. And faithfulness is basically how we formulated faithfulness is we are using 2 LLM calls. And the first one is we are given a generated answer. We are trying to figure out what is the number of statements in the answer, and we see if these statements are supported from the retrieved context. So faithfulness is a measure of the hallucination that is there in the generated answer. And hallucination in our definition is if the LLM is generating anything that is not supported by the context. And with this faithfulness score, we can get a measure of that. And the next one, answer relevancy, is a measure of how relevant the generated answer is to the given question. So here you can see that for the same question, the last answer is the most relevant and to the point. And this is the answer relevancy score is a measure of that. So basically what we do is we try to reverse engineer the answer given, the question given an answer, and we calculate the similarity between the generate. We run this like 3 times, and we try to figure out the similarity between the generated question. And if the similarity of the generated question is very high, we know that the answer is also very correlated, is also to the point.
The next part that I will focus on is the context. Now we have presented 2 matrices that can evaluate the generation part. Now we'll focus on 2 matrices that can evaluate the retrieval part. So first thing is context relevancy, which is used as a proxy for for precision of the retrieval context. So this helps in optimizing the chunk size, and to calculate this, the problem is formulated as a candidate sentence extraction. So it's pretty simple. When given a retrieval context and question, the LLM actually extracts a number of sentences that can be used to answer the given question. So the final score is the ratio of number of extracted sentences from the given context divided by the total number of sentences that was retrieved by the retriever. So this can be used to optimize the chunk size and decrease the chunk size, which can lead to saving costs and also latency. Next one is a context recall. This is a very newly introduced metric, and this is where a lot of problem happens, and estimating the recall without a reference is a tricky problem. So to run Ragas context recall score, we need a ground truth annotated answer. And this is also formulated as a combination of candidate sentence extraction and natural language inference. So given an annotated answer and retrieved context, we figure out the data points that are present in the retrieved context and also are missing from the retrieved context. And the final score is just the precision from these 2 points, calculating recall from these 2 points. Then on top of all these matrices, we apply self-consistency trick to ensure a high reproducibility and consistency of Raga scores. So basically, LLMs have proven to give consistent output when they are highly confident about a certain output. So this confidence can be measured and estimated by invoking the LLM multiple times and quantifying the agreement between the generated answer in these multiple invocations. We use this trick on top of these matrices to ensure high consistency in Raga scores. So that is it. And then we have future directions. We are working on a test set generation paradigm. So we have seen that formulating a test set is kind of difficult because it should follow certain characteristics, such as it should have a distribution similar to test set. It should also have different levels of questions in it with different levels of difficulties. So we are generating a paradigm to generate questions from a given set of documents, and if you have a seed test of prompts, that it will also consider those prompts. So apart from that, we are also working on evaluating and adversarial testing LLM agents, which is mostly used in combination with retrieval augmented generation systems. And then after that, we are looking forward to develop our own custom models for evaluation. That's all about Ragas. So you can check out Ragas in the following link. We'll also share this slide in the chat. And if you wish to chat with us, just drop us an email at team@explorertradings.com. Thank you.
Awesome. Thank you guys. So, okay, I have a few questions, and maybe and we'll do those before maybe moving on. But if other people have questions as well on the panel, please jump in. And then if people have questions in the chat, drop them in the chat box, because I think there's a lot of stuff here that I want to unpack. First of all, though, just like basic, even setting the scene, like I'd love to understand, like, are you guys working on this full time? Is it the 2 of you? Is there a company behind this? Is it just purely open source? Like, what's the story behind the repo?
Yeah, so currently it is an open source repo. We are like trying to form a company around it, but not necessarily around Ragas. as a not necessarily around Ragas. So yeah, right now it's an open source repo. We are trying to see how the adoption goes, and then we'll figure out the rest.
Awesome. Well, you've got a lot of fans. I saw one person in the chat say that they use it in their company every day. So you've got a lot of fans for Ragas. A more technical question I have is you presented like the 4 different areas that you kind of like measure on. When you guys see like applications that are producing a wrong answer at the end, which of the 4 like most contribute to that? Do you have or yeah, which of the 4 are most kind of like relevant, or you see most people kind of like stressing out about, or that's where like most of the errors occur?
Yeah, it is mostly with the context, like the retrieval part, because building up a system that can retrieve, like there's a lot of things that go. So like all of the clients that like have been using that we talked to are at the edge of what a simple vector search and a similarity search stuff and can do. So that you need, like they are trying to figure out much more comprehensive ways of retrieving the information that can actually be used to answer the question. So that is where like context recall, that is something that we added just yesterday, we feel would really help.
Got it. So context recall, that makes sense. And then one interesting thing for one of the ones, not context recall, but the other one, in context, you said like context relevancy. You said like changing the chunk size could help kind of like with optimizing that. For the other ones, like how would you recommend fixing all of them? Like if something's going wrong in context recall, what can I do? If something's going wrong in like generation, like what do I do? What are fixes for all these issues?
Right. So especially for context recall, if we say, in most cases, it is either the embedding, it is the issue from the embedding that either the embedding is not really suitable to retrieve the kind of information that is required for the given question, or even in some cases, this can be also solved by kind of query transformation. So either of these methods works many times, but basically generally improving and enhancing the retrieval techniques and embedding usually works to improve context recall so that you don't really miss any point that is necessary. So this is very, very common error after we build a simple RAG system when we push towards production. So optimizing that is very important. Regarding context relevancy, it is a matter of precision. So the LLM will answer the question correctly, mostly even if the system has low precision, but it will usually take more time because you are sending more than required number of tokens to the LLM, and it is also going to cost much more. So this can also, in some cases, cause some form of hallucination because you are presenting a whole lot of information that is more than required to the LLM, and it can mess up some of the long context. It can cause some of the long context issues with LLM. And for the generator part, regarding faithfulness and relevancy, adjusting the prompt and doing some kind of transformation usually works to improve the prompt. People also use some kind of guardrails to ensure that none of the sources, all of the sources which are cited actually have the things that are actually generated. So yes, these are the main points that we have seen.
Yeah, also I wanted to like mention the role of LangSmith, and this is like one of the main reasons why we were like super excited with the collaboration, because like very good, like LangSmith has been like super useful for us even internally to figure out where exactly, because it gives you the whole trace of the right from the evaluation and to the trace of the actual chain. And that means you have like it is much more easier to pinpoint where exactly and what exactly went wrong. So we like having a very good like tracing and monitoring setup with your evaluation pipeline as good is also something that's like very useful.
Yeah, and I know one of the big things that we're like struggling for is good metrics to evaluate all these things. I think LangSmith provides pretty good kind of like visibility into what's going on, but I think when paired with some of these metrics, I think it makes it even more powerful. And actually that leads me to another question, which is like, how much would you kind of like blindly trust these metrics? Like when you guys are doing them, do you like, how much do you look at the individual data points? Actually, maybe there's a better way for me. When you guys look at the individual data points, how often do you see that the grades are like correct and like you agree with the LLM assisted evaluation?
Right. So for our own evaluation, we have a set of human annotated test set, and whenever we roll out a new metrics, we measure the correlation with human judgment against our metrics, and if that is above a satisfiable level, that is around more than 0.8, we will only roll out the metrics. So we have this internal testing mechanism through which we test these matrices, and also, as Jitin said, LangSmith has been very useful when debugging, because whenever we formulate a metrics, some of the data points or some situations, the metrics might mess up, and we can use LangSmith to identify why it messed up. So it's been very useful, but we generally follow this testing mechanism inside Ragas to ensure the metrics actually works.
Yeah, and there are times when it does mess up, but I have been like surprised with the number of times it actually got things right. So that has been surprising, but that is something that we have to improve so that there is more guardrails and these like metrics are much more reliable. But we do these like tests as Shani said.
So a somewhat related question for this that's in the Q&A right now, and was sort of matched one thing that I had personally. One of the nice things that you do is you take these 4 metrics and you take the harmonic mean for an overall score, and you can make that a little bit easier to be filtering your results between models then, because you have that single combined float value. A lot of people coming maybe from the more traditional ML space will perhaps already have implemented or be familiar with other metrics for retrieval, like a mean reciprocal rank, where you have like a labeled data set and you want to see if the retrieved documents or something or like show up there, or maybe like precision at K. How do you think about extending like the existing metrics set within Ragas to include other metrics, either LLM assisted or some of these traditional things? And like how would you go about using that in order, like for your overall workflow?
Yeah, that's a very good question. So like there are like all these existing methodologies and they work like really well. One of the reasons of like trying to leverage LLMs were situations when like actually building a test set to like, so if you are using like if you are running the traditional metrics for like information retrieval to calculate the retrieval score, you have to have annotated data sets for the given for your given like distribution that you're trying to build. And when people are starting off, and like even if they are more forward, building such a test data set is very complicated, and that's why we like focused on reference-free metrics. But like if you can leverage the existing like systems, like existing metrics, that is a very like valuable point. Like it will be pretty useful.
Awesome. I think we can probably, there's a lot of other questions. We'll get to them at the end. I think there's a lot to dive in here. Will, do you maybe want to chat about some of the stuff we're doing on the LangChain? I guess we already mentioned a bit about how it integrates to Ragas and everything like that, but anything additional to add, or any additional experiments we've done?
Yeah, I can keep it pretty short. I can highlight 2 things. One, we have a cookbook, and I'll walk through maybe some code just briefly there to share some information of how you can get started. Actually, maybe I'll pull up the notebook that you have in Ragas so that we can continue in this theme, show how you're integrating there, and then we can show a little bit of a glimpse in the UI to see like maybe you have something that goes wrong, and then you can drill down into the retrieve pipeline in order to see what's happening. Right here, I'll share my screen briefly. So this notebook goes through a much simpler metric, and it's reference-based, so not reference-free. We're just measuring the correctness of the overall end-to-end system response on your retrieved system. And I'll just walk through briefly how to connect it to LangSmith there, and then go through a couple of the data points there that maybe it gets wrong. Overall, this is an easy thing to get started if you have a small test set that you have labeled and you know the answer. It's less useful if you're still trying to mine that information. You don't have the actual references that you want to build up. And it also maybe doesn't provide as much of a detailed analysis there by breaking it down into those 4 different quadrants, which is why we like to be able to be flexibly defining custom evaluators and linking that to things such as Ragas there. The overall process really is the creating of the data sets, and then defining the system, and then you want to evaluate in LangSmith, and then you can start iterating there. And it creates some results that look something like this. The thing that I think LangSmith really helps with here is that it can help you curate this data set. It's often kind of hard to start from 0, and you can do things such as synthetic data generation or other things, but by collecting traces of your actual system in a beta deployment, then you can see real questions that your users or that you are generating on the actual corpus you're doing, and then you can go through and correct any retrieved answers and create that really right there. And so in that way, you don't really have to start from this 0 and start checking the performance there. Here we have an example where you just write out the questions and answers. This is over LangSmith documentation. Create the data set, and this is, I'll share the link afterwards, so I won't belabor the code too much. And then you evaluate the chain. We just use a QA evaluator, which essentially asks if it's correct or incorrect, given the context and given the labels. Again, very simple. And I think it is important to bear in mind that those weaknesses in LLM-based evaluations, it does sometimes get biased towards the position if you have specific answers it's trying to select from. And it also can have systemic bias in certain things, where if it has some knowledge in its parameter space, it might be disagreeing with the actual ground truth answer you have there, especially if there's some errors in the tokens or something there. You can run the evals, and then you can see the results in LangSmith. And what this gives you is this aggregate metrics there, but then also it gives you an entire audit of each data point in the data set, so you can see which documents were retrieved for that data point, the OpenAI call or the other LLM call in order to synthesize the response, the query generation step if you want to be rephrasing the query into some other steps there, and then all those types of things. And so then whenever you see that it is incorrect or see that it is correct, you can drill down into which part of the component is actually failing. Often it'll be that the documents you're retrieving are all too similar or insufficiently relevant. And again, using something like Ragas would help provide that a little bit more direction at a top level. But then you can actually go and then make tweaks to your system and improve the metrics there. Another pretty cool thing, actually, I'll jump over to the actual demo. I'll jump over to actually LangSmith now so that you can see what it looks like. So this is a run that we did. I just generated a random project, so that's not super informative. But you can see the results here on how accurate it is. And it looks like it got most of the answers correct. This is a relatively easy data set. Let's see when it got incorrect here. You can click through to each of these different steps. You can see which documents it retrieved here. You can see that perhaps the format of this isn't the most useful for all of the information. And then you can also go to the feedback run. And you can see sort of the reasoning that it went through, what information was passed to the evaluator, and then how it was making the decision here. So you can see this whole prompt. And if you disagree with it, you can open it in the playground. You can make changes to the prompts there so that you can maybe improve your evaluator for the next time you're running it. I think we provide some off-the-shelf evaluators within LangChain. I think extending to things like Ragas to other things can give you a lot more flexibility whenever you have special criteria, or you have special types of user-specific evals or considerations you want to be including, because not all retrieval augmented generation pipeline is the same, and not every system wants to have the exact same like decisions whenever you're doing that. So I can try this, and then I can make changes, and then you can submit it and see what types of results it returns. And then you can use that next time whenever you want to be evaluating.
Do we have any Ragas evaluators built in?
Yeah, maybe Jiten, do you have any shared results for it? I haven't run it recently, so I don't have a link on hand. Maybe I could actually go through and run your notebook.
I think we're probably a bit short on time to do that live, but maybe we can drop a link to that notebook, and because I think yeah, like the metrics that you guys kind of like have pair super nicely, I think, with like the debuggability and inspectability. So I think it's a really powerful combo.
I think one final thing before we move on, I think like the things that are really like are great about being able to integrate like Ragas and LangSmith is that with Ragas, you can get started without having a labeled data set. You get all these great metrics, and you can look through at the results. And then from that, you can use LangSmith to help investigate things. You can make disagreements with that, and then continue to curate this data set so that it's more reliable, and that the types of evaluation results are more correlated with what your human judgment would be. And so like with this, it can be more of a flywheel, and then you can also adjust it to be more specific to your domain. Like maybe your generation pipeline is very focused on the specific domain of problems, and maybe you want to be focused on specific information there. Maybe the hallucination metric, you want to include additional things in apart from the retrieved data that is very specific to your context. You can use that to have things that are very specific to whatever you want to be deploying.
Awesome. And yeah, Jithan just shared a example or the notebook in the chat, so people should definitely check that out. All right, so now let's move on to the final presenter, Pedro, who is actually building something. He's the only one here building an application instead of tools. So maybe you can start chatting about Noah and the product that you're building, and then also, how do you think about evaluation? Like, there's all these different techniques. What are you actually doing in practice, if anything at all?
Totally, no, and I appreciate the time, and the presentation was great. So for starters, with Noah, we just try to bring the ChatGPT experience, but with a lot more context on the user. I think right now users just go on their documents, copy and paste, and try to always bring context manually to ChatGPT. And I think retrievals and our infrastructure is very good enough to create an automated system that we just get the documents that are relevant to any workflow, and the user just talks to the chat, assuming that the chat can retrieve the best piece of context. So we built Noah to have an experience that users just come in, they integrate with Google Drive or Notion, they populate in hundreds of documents, and then they can just start chatting with them without necessarily knowing where exactly the documents are or certain keywords. It's just finally a co-pilot that can help people, generate things or find things, or, find out of whatever use case that application is relevant. And for us, evaluations is interesting because it's a horizontal model. So we're not particularly optimizing for accountants or lawyers or any other profession. We want that to be horizontal and multi-purpose. So whenever, we try to optimize for a specific workflow or a query, we usually find that it hurts the general performance of the system. And then we usually go back to, well, is this just a pure retrieval the best way to go about it? So I'm excited to share a bit of the learnings that we found in building the system and user input. And usually user input was a North Star for us. Usually it's pretty binary. They say either the answer is good or the answer is completely out of the way. So this is kind of a matrix that oh, sorry, I shared it wrong. So let me present it here. So let's see. Yeah. Okay. So the matrix is we built and we optimize, we try to optimize for a bunch of the factors that are involved in retrieval: chunk size, quantity, putting a lot of intermediary chains to try to get a better answer. And what we found is that usually the users will be happy with an answer when the model captures the right chunk, and if the chunk is big enough to provide a very good answer. So we tried with we tried with retrieval with very few big chunks and with a lot of chunks that are medium sized. And there's usually a balance there that like the chunk needs to be big enough, but also there needs to be some of them so that there's a complete context being captured in the LLM, and then the answer is usually going to be satisfactory. So that we found that to be the best parameters to provide the best answer to users, as opposed to chains that deduce what needs to be done, and then that agent or chain deciding documents to search through, or things to do. So relevant chunk size and quantity were very important for us in a more pure retrieval system. And then of course, context size is really key. We try not to partition our queries in a lot of chains. Usually just 1 or 2 chains with the user input, the vector retrieval, stuffing that into a chain was very good to get good answers. Intermediary chains are good sometimes because sometimes users are like, compare information from this document with information from this other document, and then you kind of need a chain to understand that you need to do 2 vector retrievals to get chunks from different queries. That was really good for optimizing for this type of query, but it wasn't good for overall performance, because every query would hit into that chain, and that would hurt our latency, and that would usually also hurt the quality of the output, because it would get repetitive chunks and then it wouldn't be as good. So we honestly found that a more pure high quality retrieval is what right now yields the best answers to users. And then I think the factor to optimize for is that when the user data set has outdated or conflicting information, the LM is crazy, because one chunk says one thing and the other chunk says another thing. So we just try to make sure that whenever the user is uploading their documents, that they don't take like, the best solution was to not take 2 old documents, because usually if you're talking about product strategy or sales metrics, you're going to have documents from 2019, 2020, 2021. But if you remove those documents out of the way that are not relevant anyways, you're going to get very good answers. So you just make sure to not upload older information. That was better than to try to optimize that in chains. It's like, oh, you have 2 different chunks. One is newer, one is older. Just prioritize the newer and give a better weight for that. That was a good chain to do, and that worked well for those queries that had those conflicting information going on. But it wasn't good for the overall model, because again, we're trying to optimize for people in multiple industries using it for their own use cases. So that wasn't a good optimization considering the overall performance. And then just lastly, users are very generous. So if they ask something and it doesn't go, they try to be more specific in their queries. I think historically, before LLMs, search and working with documents has always been a keyword type of effort. So they're very used to being specific with their queries, which really helps retrieval. They're really usually they're like, go on this document and summarize it, or they're very good with keywords, which really helps performance of our software, because it just really helps retrieval. And then memory is really hard to optimize. I think I'm still trying to crack the code there, but memory is usually a prompt that you pass, and any word or any information that is weird, it usually messes with the ultimate output. So for us, just getting the last message is optimal for memory. So whatever the user said before, that's the only piece of context that we give the LLM in the subsequent chain as memory. If you add more, it kind of goes into that issue of a lot of conflicting information that is weird, and then the LLM doesn't know what to do. And I think there's probably a sweet spot memory prompt that ChatGPT uses that they don't share, but that's usually probably going to be the gold standard. Text for retrieval is amazing. So tabular data, Notion, HTML. I think it still depends on the quality of the loading, but that's still not 100%. And then the prompt needs to be very pure. It needs to be very okay. You retrieve the chunks, and then you just ask based on the context, give an answer. If you add you're a helpful salesperson, or if you're a happy person, or anything, there's a black box around that word that's going to hallucinate the final answer. So being as pure and as concise as possible in the prompt after the retrieval is done is really the best for preventing hallucination. So those are a few of the learnings that we had in talking to users and building Noah to ensure that the evaluations are good. But yeah, it's been a very empirical process of talking to users and making sure that chunks were retrieved, answers were satisfactory, to make sure the application works best for everybody.
This is super interesting. And so, yeah, so one of my questions was going to be exactly what it sounded like you were talking a little bit towards the end. So you have all these learnings, and when you're saying like, oh, we found this to be better than this, how exactly did you find that? Was that like collecting thumbs up, thumbs down feedback? Was that purely kind of like running it with users and asking them what they thought? Like, how exactly are you doing kind of like the
Yeah, so it's a mix of all of the above. So thumbs up and thumbs down are really relevant to us. So we can just, if users are open to it, whenever we see a thumbs down answer, we hop on a call with the user and we look on the backlog and see, okay, like, did it get the right chunk, or why was the answer bad? Usually a bad answer came from a retrieval that didn't get the right chunk, either because it was stuffed somewhere hidden, so that the retrieval wasn't, smart enough, or it usually happened in data that wasn't properly loaded. So, data that was in a CSV, or data that was in a slide or PDF. For text, for straight text, it was really good. But yeah, so usually, we saw that, a thumbs down, or we shadowed users using it to make sure that, they had, we just wanted to see, okay, users are typing, go on my product strategy launch document and generate 4 more ideas, and just like seeing how the users use it, and if the retrieval was able to capture that was really helpful in understanding, okay, like those are things to optimize for. And usually the chains that we try to optimize with the ideas that we have usually are not the right ones, considering how the users use it. Users are very keyword driven. So yeah, that is what we found.
Super interesting. More specific questions I have. You say like text-based sources perform the best in vector retriever. Is this opposed to like PDFs, or like, are you guys you're not doing multimodal yet, are you? Or?
Yeah, so we're doing all types of data sources, so CSV and slides and everything. But straight text is the best, just because it's the simplest to load. We usually the most tricky to load for us is Notion, because it's a huge HTML that you have that has so many components that you have to load properly and to ensure that it's connected with the other components, and that's a full chunk. So that's tricky for us, and sometimes very important context is split across 4 or 5 chunks, and the retrieval is not that great. So that's what I mean by that. Usually straight text, when you vectorize a straight text, that performs really, really well, and it's still getting there for like for CSVs and other types of data. We would do them, and we have good responses, but it's still not 100%. And I do think that as agents evolve, and as GPT-4 gets faster, and those things happen, we're going to see an ability to really query information from those as well.
Awesome. And then the last question I had, you had one bullet point that was like, generous context length is key, or context size is key. So there's been like some talk around like, as the context windows gets longer and longer, the LLMs kind of like forget what's in the middle, and so maybe there's actually some diminishing returns. Have you seen that in practice, or?
Yes, we actually have. So it goes as a parabola. So you have to give enough context so it answers. But if you could put 9,000 tokens of context and ask a question, you wouldn't get, like, it would be better to have retrieved a 4,000 token chunk and gotten the answer from it. So we actually found that really small chunk size is really, really bad because it's just kind of a keyword search. So you need to be able to retrieve at least, a page worth of context that is around, the hotspot of the answer. But yeah, as you really, really, amplify that, you do find that diminishing return happening. So, but it's important to strike that balance, because very little or too much really hurt.
Super interesting. All right, there's some good questions in the chat, so let's maybe jump there, and some of them are maybe more relevant for Ragas, and some of them are probably more relevant for Noah. So I'll try to pick a combination of all of them for the next. I guess we got like 8 or 9 minutes. I think this one's for the Ragas team. So you guys mentioned that sometimes the embedding model is inappropriate for the corpus. And this is, are there evaluation metrics that point to that as a cause, as opposed to some other defect in the RAG pipeline? And maybe more generally, like, when all of these steps go wrong, how can you kind of like know what's the underlying cause of it, whether it's like the embedding model or the chunk size or anything like that? Are there any heuristics or best practices that you guys have observed? And Noah, I think, or Pedro, I think you're still sharing your screen. So yeah, I think you turned off your video instead of unsharing your screen.
Oh, that's
They're
right.
very
How can I? Oh, stop sharing. Oh, wow. I see.
Yeah.
There we go. It is on the Chrome tab.
Yeah. Yeah. So to answer the question, I think in general, when the embedding, when there is issues with the embedding, the retrieval does not retrieve any or the information which is required to answer the question. So in that case, most cases, context recall is the one to look at, because the context recall will be low because it does not really have the amount of information which can be used to, which is necessary to answer the question. So yeah, so another situation can be again chunk size, where contexts are split across multiple chunks, and it only retrieves the chunk partially or maybe some of the chunks to answer the question. So again, in that case, context recall is something which is very important in case of optimizing the right embedding metrics. So yeah.
Super interesting. There's a series of questions around basically like what traditional methods of assessment does Ragas compare / compete with, and can you even use them in conjunction? How do you guys think about that? Like, what are traditional metrics for kind of like retrieval or question answering, and how does Ragas compare? Can you use them together?
Right. So most of the traditional metrics around generation is or was generated or was implemented pre-GPT era, and generation quality itself was subpar. And these metrics is mostly, and also works mostly with only an annotated ground truth. But in case of Ragas, it mostly focused on reference fee evaluation, and hence these things are actually a little bit different to compare apples to apples. So we don't really compare it to the traditional methods, but yeah, I mean, if you have got answers which are particularly short form, one can even go with traditional metrics instead of using LLM assisted, because short form answers are particularly easy to compare compared to long form answers.
Awesome. Pedro, I think there's 2 cool ones for you. The first one, you mentioned, like, people would love to learn more about how you deal with stale and outdated information. This is a very painful problem. So yeah, you mentioned, like, from what I understood, you actually kind of like put the burden a little bit on the user in terms of like trying to get them to upload only the most relevant things. Is that correct? Do you do anything else to kind of like safeguard that? Did you try anything that didn't work even?
Yeah, so we did try to wait out older So whenever retrieval happens and chunks are very disparate in their date, we really try to give a better weight to the newer chunk. It was just tricky to pass that on a general chain of do you have to do that or not. So whenever we did that, it worked best for older chunk for this issue whenever you have those chunks happening. But it hurt the overall performance of the whole system because then now every query needed to be passed into a chain and needed to decide, do you need to go into this chain? And that hurt everything. So users are really good at, okay, like they ask a question that's very directed, right? So they're like, find me the product strat. They usually set a timeline for their query. So the product document of last year or the product document of this year. For our uploads, we try to restrict very old documents. So for whenever we're uploading things to Noah, we only take documents up to January 2022. That way you avoid having documents from 2015, those very old documents that have very different information. So putting the burden on the user is really good because, you don't have to overly optimize for outdated chunks because they're not relevant to the user anyways, right? So the user can just choose, okay, we're going to put on only the relevant documents that are usually the newer ones. And then, so you just don't even have to put them into the pool of retrieval anyways, because that just causes a lot of problems. So yeah, we try to optimize with the chain. It just hurt overall performance.
Super interesting. And then the other question that I think is really interesting is, how can Noah answer questions that need to aggregate data across different documents? And how do you handle that?
Totally. And that's key when you're setting up the number of chunks retrieved parameter. So everything is, vectorized, and then the retrieval retrieves chunks that can be from a lot of multiple documents. You're going to have one or two chunks that are the hotspot of the answer that will come from one document, but the more chunks you retrieve, the more likely they come from different documents, and then they aggregate into a chain, and then the chain is multi-document. So increasing the number of chunks retrieved just maximizes the chances of you getting chunks from multiple documents, and then if they're relevant, the LM will be really good at including the context into the answer. So yeah, we just make sure to put a chunk size that is big enough, so that a chunk size retrieval that is big enough so that you get usually context from 2, 3, or 4 documents. So usually when Noah provides an answer, we cite the sources, and usually it comes from one source, but a lot of times it comes from 2 or 3.
Yeah. Interesting. Do you have any sense of how many questions are about multiple documents? Or are most of them just about one document?
I'd say 40% are about 2 or more.
Okay.
Yeah. So usually most are about one document because the user is okay, go in the document and asks something, and then even if it retrieves chunks from other documents not relevant, the LM cuts them off. But in a lot of times, you have 2 or 3 documents that have something relevant that is sometimes 10% of the chunk, but that really helps the final answer. So making sure that you're retrieving 5, 6, 7 chunks, and then passing that burden of deciding if they're relevant or not to the LM is really good. And then you have a multi-document answer.
Awesome. And then last question, and this came up a few times, so I think it's a good one to end on. This is probably mostly for Will and the Ragas guys. Around the data that you evaluate, where should this come from? How many data points do you need? How do you generate this? How a lot of people how can I come up with data to actually evaluate and get these metrics on?
Do you guys want to answer that first?
Yeah, you can take it. Yeah.
Yeah, so I guess so from the LangSmith side, I think one of our main value props and interest is that we want to get data that's as representative as possible to what you're going to see in production, and we want it to cover the full distribution of use cases. Whenever you're putting a system into production, you care about average performance. You want to get that P95 performance, and similarly for the retrieval quality and the answer quality, you want to be trying to get as much cover of this tail distribution as possible. I think this is really where LLMs are useful, but also where it's like becomes a little bit hard. And there's like obviously considerations around privacy and everything, so you can synthesize different things that are representative there. In terms of like how like the like tactics to do this, there's definitely tools like Nomic and other things that use vector distances. I'm not sure how useful those are. What I've found, and would love the Ragas folks' opinion on this, but I found it quite useful to start with a small one and then try to extend in different dimensions and see where the existing system fails. And then I can manually annotate or use like assisted annotations to then gradually build that out so that you have it still be pretty high quality without just going for this huge quantity that can slow down your eval process.
Awesome.
Yeah, I agree to Will's points, and as in the test set should be very reflective of what we see in production. And there are some automated tools which we can do and methods to filter prompts or the test logs so that you can automatically formulate a set of a small test set from the ones you see in production. This can be something like automated deduplication and filtering out prompts that represent data points from different data points. So yeah. And I think LangSmith is particularly useful in manually selecting test set curation.
All right, awesome. That about wraps it up for today. I think this was super interesting. Lots of great learnings on all the metrics that Ragas has. And Pedro, I really liked I think you had 8 different bullet points. Those were awesome. I think those are very real world kind of like learning. So I think it was a great combination of tooling and real world application. So thank you guys so much for joining. Yeah, that's all I got. And thank you everyone for tuning in. See you at the next one.
Thanks everyone.
Thank you.